In 1944, the war in Europe was defined by a brutal, asymmetric arms race. On one side stood the American M4 Sherman medium tank, the workhorse of the U.S. Army. It was reliable, fast, and produced in immense numbers. But by the time Allied forces landed in Normandy, a critical question hung over every armored division. Did the Sherman have the punch to win the decisive battles? The early answer from the field was often a sobering no. The standard 75mm gun on most Shermans, while highly effective against infantry and soft targets, struggled to penetrate the formidable frontal armor of Germany's latest designs, the Panther and the Tiger. This stark reality drove an urgent, behind-the-scenes effort by U.S. Ordnance to field a superior weapon capable of leveling the playing field, the 76mm M1 gun. But installing a bigger gun was only the first step. The true story of the 76mm is not just about the cannon itself, but about the decades of detailed technical planning and rapid wartime development that went into the ammunition. This is a story of theory meeting reality, of data pages pulled from documents like the U.S. War Department Technical Manual TM9-1904, clashing with the brutal, unforgiving crucible of combat as documented in the after-action reports of the 4th Armored Division. Our aim is to move past the popular mythologies and get to the verifiable facts. We will utilize the public domain record, the official U.S. government sources that define the theoretical limits, the practical challenges, and the combat lessons learned by the crews on the ground. We will track the journey from the Aberdeen Proving Ground Ballistics Research Laboratory to the final push across the Moselle. This documentary will focus on 3 core questions. First, what did the Ordnance Department's 76mm gun ammunition performance data promise the tank crews? Second, how did this promise hold up in the critical engagements described in the first U.S. Army combat reports? And finally, what was the true technical impact of the game-changing high-velocity armor-piercing AFAP round? The stakes were enormous. Every engagement cost American lives and slowed the march to Berlin. Success hinged not on manufacturing might alone, but on the precise, meticulous, and often life-saving technical data contained in documents designed to ensure the quality of every single shell fired. These are the records of the Office of the Chief of Ordnance, the backbone of the war machine. The field record, particularly the experiences of the aggressive 4th Armored Division during the pursuit across France in September 1944, gives us the human and tactical perspective. It reveals the moments of frustration when standard ammunition failed, and the moments of decisive success when the right round met its target. This is the technical history of the American tanker's fight for a decisive advantage. We begin by digging into the paper trail, examining the official technical guidance that governed the use of ammunition in the European theater. The story starts not in a French field, but in a U.S. military warehouse, with a document that no tanker would ever willingly be without. Technical Manual 9-1904. The meticulous calculations of the Ordnance Department ended the moment the 76mm Sherman left the staging areas for the battlefields of France. The next chapter of its story was written in the thick, often contradictory, pages of the after-action reports. These documents, raw, immediate, and compiled under duress, detail the friction between theoretical performance and the brutal, unexpected challenges of armored combat. The spearhead of this new reality was often the aggressive 4th Armored Division, operating as part of Patton's rapid 3rd Army advance across France in late summer 1944. Their mission was speed, and their success relied on their tank guns working exactly as the manuals promised. The reports reveal that the initial experience with the 76mm was a mixed bag of dramatic success and frustrating failure, often in the same engagement. When facing older German armor, such as the Panzer IV or Stug assault guns, the 76mm M62 armor-piercing AP round was devastating. The higher muzzle velocity translated into quick kills at medium ranges, validating the work of the ballistics labs. However, the field reports quickly established two major shortcomings that backed up the technical compromises we outlined earlier. The first was the widely disliked M42 high-explosive HE round. Tank commanders, who often use their guns to bombard buildings, suppress infantry, or neutralize anti-tank gun positions, found the new HE shell lacking in fragmentation and concussive power. The 4th Armored Division, after action reports for September 1944, contain numerous complaints about the shell's reduced effectiveness, with some units reporting they wished they still had the older 75mm guns HE round for fire support. For a tank crew, losing their primary infantry support weapon was a major tactical blow, regardless of their anti-tank capability. The 76mm Achilles heel was proving to be its inability to be a truly effective all-purpose weapon. The second, and far more critical, challenge came when the 76mm Shermans met the true heavyweight of the German defense, the Panther medium tank. The initial engagements of the pursuit across France provided the U.S. Army with its first mass-scale data on this specific matchup. The first U.S. Army combat reports detailed instances where M62 AP rounds simply failed to penetrate the Panther's sloped glacis plate at ranges considered standard for a tank duel. These reports were devastating, showing that while the round had the potential to penetrate under perfect conditions, the reality of sloped armor, slight angles of impact, and rapidly closing distances meant that the advantage lay heavily with the Panther. One persistent issue, confirmed by many armored unit reports, was the muzzle flash problem. As one unit reported, the blinding flash and subsequent dust cloud made it impossible for the gunner to see where the first round landed. In the high-pressure environment of a tank duel, the inability to immediately correct aim was lethal. If the first round missed, the Panther had ample time to traverse its powerful 75mm gun onto the firing Sherman. The gun's high velocity, meant to be its strength, became a tactical liability. These reports were not just dry statistics. They were direct pleas for better ammunition. They highlighted an unnerving truth. The 76mm Sherman, the U.S. Army's best available counter to the Panther, was at a severe disadvantage in a frontal engagement. Tankers were often forced to risk dangerous flank maneuvers or rely on overwhelming numerical superiority to defeat a single well-positioned Panther. The reports also documented the psychological toll. Knowing that your standard anti-tank round might not penetrate the enemy's armor at standard ranges severely damaged confidence. This lack of confidence in the war machine itself was a combat factor that could never be quantified in a ballistics table. The urgency of this problem led to a frantic search through the ordnance archives for a quick solution, which brought the focus back to a niche experimental round, the M93 High-Velocity Armor-Piercing, or HVAP. The introduction of this silver bullet was the military's attempt to reconcile the devastating truth of the combat reports with the data-driven promises of the proving grounds. The field reports from September 1944 show a pivot in tactical thinking. Instead of relying solely on the technical superiority of the 76mm, commanders focused on exploiting its great strength, mobility. The 4th Armored Division's success was less about winning stand-up slugfests against the Panther and more about avoiding them by rapid movement and maneuver, ensuring they hit the German war machines in their vulnerable flanks. The gun was used to hold ground, while the mobility was used to win the battle. The data gathered in the heat of battle over those critical weeks proved that while the 76mm was a necessary upgrade, its standard ammunition still left the American tank crew fighting with an Achilles heel, a vulnerability that had to be overcome by exceptional tactics and the rapid deployment of specialized technology. The deficiencies of the 76mm were not just a problem for tank crews. They were a systemic challenge to the U.S. Army's entire combined arms doctrine. American military strategy relied heavily on the ability of the tank to support infantry by dealing with enemy strongpoints, machine gun nests, and anti-tank guns. This role was traditionally filled by the high explosive, or HE shell. The The technical manuals revealed the 76mm M42HE round was smaller and weaker than the 75mm version. In combat, this deficiency was crippling. When a Sherman advanced against a defended village or a reinforced trench line, the crew needed a powerful fragmentation burst to neutralize threats before the infantry dismounted. The 76mm M42 often failed to provide this necessary concussion. Infantry commanders began to report that enemy troops, previously pinned down by 75mm fire, were able to ride out the lighter bursts of the 76mm. This forced the tank to move closer to the enemy, exposing it to infantry-carried anti-tank weapons, or forced the supporting infantry to attack without the requisite preparatory fire. Military historians, such as Hugh M. Cole in the official U.S. Army Center of Military History monograph, The Lorraine Campaign, highlight this constant reliance on HE fire. When the M4 76 tanks were tasked with fire support, they were technically inferior to their 75mm counterparts, complicating every single offensive action. The trade-off for better anti-tank penetration was a profound reduction in general-purpose utility, a cost that infantry and armored units paid daily in the field. But the most dramatic and dangerous challenge remained the face-to-face confrontation with the German armored giant, the Panther tank. The technical compromise of the 76mm standard M62 armor-piercing round was revealed in a series of engagements across the open ground of France. The first U.S. Army combat reports detail numerous instances of the 76mm round striking the Panther's highly sloped glacis plate and simply disintegrating or failing to penetrate the thick armor. Consider a composite scenario drawn from the combat reports of the aggressive 4th Armored Division during their September 1944 drive toward the Moselle River. A column of Shermans encounters a solitary Panther positioned to cover a road junction. The 76mm Shermans immediately recognize the threat. They take up firing positions at an estimated range of 800 yards. The first Sherman fires. The muzzle flashes, even without supporting visual records, are blindingly obvious to the German crew. The round strikes the Panther's sloped frontal armor, a perfect hit technically, but the American crew cannot see the result due to the massive dust cloud created by their own gun. If the round penetrates, the Panther is knocked out. But if the round fails to penetrate, the Sherman is now precisely located. The after-action reports confirm that in these specific scenarios, the M62 round often failed. The 76mm high velocity was countered by the Panther's superior armor geometry, and the technical data was overruled by field performance. The Panther, meanwhile, could fire its high-velocity 75mm KVK-42 gun with relative impunity. Its ammunition was superior to the M62, and more importantly, it was firing against the relatively thin vertical armor of the Sherman. The resulting engagement often devolved into a frantic race by the Sherman crews to find a flanking position before the Panther could acquire a solid aiming solution. The psychological dimension of this technical failure cannot be overstated. Tank crews are trained to rely on their war machine's capabilities. The knowledge that a well-aimed shot might simply bounce off the enemy's front plate, while knowing the enemy's return fire will almost certainly penetrate your own, is a profound loss of confidence. The American tank crew was forced to fight smart using superior communication and maneuver, while the German crew could rely on the sheer technical superiority of their war machine's armor. This disparity created an urgent need for an analysis of kill ratios. While official post-war studies would vary widely, the field reality reported by the 4th Armored Division showed that defeating a Panther or a Tiger often required a minimum of 3 to 5 Shermans engaging simultaneously. This was not a function of poor gunnery. It was a function of the technical data of the M62 round being insufficient for the task it was being asked to perform. The technical specifications of the gun, while an improvement over the 75mm, were still the Achilles heel in the direct tank-to-tank fight. The Ordnance Department had designed the 76mm to defeat the tanks of 1943. By the time it was widely fielded in 1944, The Germans had already deployed tanks that rendered the standard ammunition technically obsolete for frontal engagements. The consequence was a significant tactical shift detailed in the combat reports. Commanders of armored divisions placed new emphasis on reconnaissance and ambush, ensuring that 76mm Shermans only fired at vulnerable flank or rear armor. The crews were explicitly instructed to aim for the mantle or the weaker side armor. This meant that the true metric of the 76mm's effectiveness was not its frontal penetration, but the crew's ability to use the Sherman's mobility to deny the enemy a frontal shot. The pressure on the U.S. Army's supply system became immense. Every after-action report that mentioned a non-penetrating hit on a Panther was an implicit demand for better ammunition. The Ordnance Department had to accelerate research and production on the only round that offered a technical solution, the hypervelocity armor-piercing round, or HVAP. Without this specialized ammunition, the 76mm gun risked being permanently relegated to a secondary status, struggling to fulfill its role as the American armored spearhead against the German war machine. The battle reports from September 1944 were, therefore, a massive technical audit. They forced the military bureaucracy to immediately reconcile the clean, theoretical performance data with the messy, lethal combat data. The next phase of the war would hinge entirely on the ability of the U.S. industrial and research complex to deliver a solution to the front lines, a silver bullet that could restore the technical superiority needed to win the armored duel. The reports streaming back from the battlefields of France were unambiguous. The standard M62 ammunition for the 76mm gun was insufficient to consistently deal with the German Panther in a straight fight. This urgent reality pushed the focus back to the only technical option that promised to turn the tide, the high-velocity armor-piercing round, known officially as the M93 HVAP. The HVAP round was nothing less than a revolution in ballistics, and its story began long before the war at the Aberdeen Proving Ground Ballistics Research Laboratory. Engineers had been developing the concept of a subcaliber round, a projectile with a dense, small core housed within a lightweight shell. The final product, the M93, consisted of a dense slug of tungsten carbide, which is nearly twice as heavy as steel, encased in a simple aluminum body. The genius of the design lay in its physics. The lightweight body allowed the projectile to be fired at an incredibly high muzzle velocity, far faster than the standard M62. Once the round left the barrel, the aluminum casing peeled away, leaving only the dense tungsten core flying toward the target. This small, concentrated mass of metal carried enormous kinetic energy upon impact. The results from the initial Aberdeen Proving Ground reports were staggering and represented a dramatic moment of triumph for American ordnance science. Where the M62 APCT had struggled to penetrate the 80mm sloped glacis of the Panther at 500 yards, the HVAP could achieve a successful penetration at significantly extended ranges. The tungsten core, with its highly concentrated energy, could defeat the sloping armor that caused the conventional rounds to shatter or deflect. This data confirmed that the United States now possessed a technical counter to the German war machine. The Achilles heel of the Panther's frontal armor was finally exposed. The M93 was the silver bullet the tank crews had been asking for. The challenge now became one of logistics and industrial capacity. While the HVAP was technically superior, it suffered from two catastrophic limitations: scarcity and manufacturing complexity. Tungsten was a rare, strategic material with many other wartime uses, and the process of machining the dense tungsten carbide cores was time-consuming and expensive. The records of the Office of the Chief of Ordnance confirm the supply nightmare. HVAP rounds were never available in sufficient quantities to become the standard round. Instead, they were treated as special issue, prioritized for tank destroyers, and for elite armored units, such as the 4th Armored Division. Crews were sometimes restricted to carrying only a handful of these precious rounds, often as few as 2 or 3 per tank. The introduction of the MM93 HVAP created a strange duality in the combat reports. When an American tank crew had an HVAP round loaded, the technical equation of the duel shifted entirely in their favor. The fear of the Panther's frontal armor vanished. However, if that one or two special rounds were fired, or if they missed, the crew immediately reverted to the inferior M62 and the grim tactical reality of Part 2. The ultimate effectiveness of the 76mm gun remained contingent on a rare commodity. This scarcity meant that the HVAP was a technical victory, but a logistical compromise. The first U.S. Army combat reports show that commanders had to make difficult tactical decisions: reserve the HVAP for absolute emergencies, or risk using it early to ensure a quick kill. This uncertainty was the final technical hurdle the U.S. Armored Forces had to overcome. The deployment of the HVAP did more than just provide a technical edge. It restored confidence. The knowledge that the war machine had a solution, even a limited one, allowed crews to engage with greater aggression, knowing that if the ultimate threat appeared, they had a chance to prevail. The integration of the HVAP round marks the point where the 76mm gun finally fulfilled its promise as a true anti-tank weapon. It was only through the rapid application of advanced ballistics research, combined with the hard-won lessons from the after-action reports, that the American tank was finally given the punch it needed to finish the war in Europe. The introduction of the M93 HVAP was not a singular event. It was the culmination of an intensive wartime industrial and scientific scramble. To fully appreciate its impact, we must look deeper into the technical challenges of bringing this round from the laboratory bench to the Sherman's ready rack. The core of the M93 was tungsten carbide. Unlike steel, tungsten is extremely difficult to mine, process, and shape. Its melting point is extraordinarily high, and it requires specialized powder metallurgy techniques for production. A process of heating and pressing the tungsten powder into the hyperdense, precision-engineered slug required for the projectile core. The entire manufacturing process was a logistical bottleneck that the records of the Office of the Chief of Ordnance documented meticulously. The Ordnance Department faced a global competition for tungsten, as it was also critical for high-speed cutting tools, armor plating, and other industrial uses. The priority given to HVAP production shows just how seriously the U.S. Army viewed the Achilles heel of the 76mm against the Panther. Manufacturing plants were quickly converted and retooled, but they could never keep up with the demand of a massive army fighting across an entire continent. This technical bottleneck directly created the severe logistical limitations that plagued the armored divisions. The distribution was governed by complex allocation formulas, prioritizing tank destroyer battalions and frontline armored regiments. Even within the elite 4th Armored Division, the supply was metered out strictly. This forced a fundamental tactical change that went beyond simply using the round. Tank commanders and gunners had to become instant experts in target recognition and range estimation, hoarding their precious HVAP rounds for specific, high-value targets. A standard engagement with a Panzer IV was an M62 job. A sudden encounter with a Panther meant an immediate scramble for the M93. The combat reports are filled with anecdotes and after-action commentary, highlighting the stress of deciding when to commit the irreplaceable silver bullet. These reports also provided crucial feedback to the Aberdeen Proving Ground teams, confirming the round's technical prowess. For instance, reports from late 1944 detailing successful frontal penetration of Panther tanks often specifically mentioned the use of the T4 M93 round. These successes were not just kills, they were pieces of data that proved the scientific solution had worked. The velocity was high enough, and the tungsten core was dense enough to overcome the geometry of the Panther's glacis plate. However, the HVAP introduced its own set of technical problems. Because the tungsten core was much smaller than the full-caliber M62, it was less stable in flight. Gunners reported that the accuracy of the M93 round deteriorated rapidly at extreme range. While it had the power to penetrate at those distances, the probability of hitting the target dropped significantly. Therefore, the war machine was still dependent on closing the distance, but now it had a reliable punch when it did. Furthermore, the lack of an explosive filler meant the HVAP was purely a penetrator. If it struck the tank's interior without hitting something critical, like the engine, fuel, or ammunition rack, it might pierce the armor without immediately destroying the vehicle. The crew was now relying on the secondary effects of the tungsten core fragments ricocheting inside the tank's crew compartment. This was a brutal form of destruction, but it was not the instantaneous, guaranteed kill provided by a massive high-explosive-filled shell. The 76mm gun's story, therefore, concludes as a testament to compromise. The technical data provided a solution, the M93 HVAP, that was brilliant in its ballistics, but flawed in its industrial reality. The after-action reports confirmed that the gun, with standard M62 ammunition, was insufficient, and the HE rounds were tactically weak. Ultimately, the technical manuals and performance data served as an accurate blueprint for the M4 Sherman's Achilles heel. They defined the problem mathematically, and the Aberdeen Proving Ground provided the mathematical solution. But it was the bravery and tactical ingenuity of the tank crews, coupled with the limited supply of that specialized M93 ammunition, that turned the tide of the armored war machine engagements. The legacy of the 76mm is not one of flawless design, but of a necessary, urgent upgrade that bought the U.S. Army time. It forced the implementation of superior tactics and paved the way for even more powerful tank armament in the final stages of the war. It stands as a monument to the technical and logistical struggle that defined the war in the European theater. The story of the 76mm gun is one of adaptation under fire. As the after-action reports poured in, the Ordnance Department and the Army Ground Forces were forced to perform a continuous, real-time audit of the war machine's performance. This final audit, synthesized in the official historical record, reveals how the Army integrated the harsh technical data with evolving combat doctrine. The crucial lesson learned from the experiences of units like the 4th Armored Division was that the fight was not simply tank versus tank. It was a race for technological parity that was won by systems, not just single weapons. The 76mm, despite its Achilles heel shortcomings, forced the U.S. Army to rely more heavily on its true strengths: fire control, communications, and combined arms coordination. One significant finding from the records of the Office of the Chief of Ordnance centered on the psychological and tactical effectiveness of penetration itself. While the standard M62 AP round was insufficient for a frontal kill on a Panther, penetration was not the only goal. A well-placed hit, even if it did not pierce the interior, could damage the optics, track, or gun mechanism of the enemy tank. The official historical accounts from the USF Army Center of Military History, such as the Lorraine Campaign, detail how U.S. doctrine evolved to focus on disabling shots rather than guaranteed kills. It was better to incapacitate a Panther and force its abandonment than to risk a full frontal duel. The 76mm gun played a critical role in this shift, acting as the primary weapon for suppression and secondary damage against the heavier German targets, clearing the way for infantry or artillery to finish the job. The technical problem of the muzzle blast, which we previously discussed, was addressed directly in the field with a bureaucratic fix. The threading for the muzzle brake was quickly made standard on new production 76mm guns, and existing tanks were upgraded when possible. This seemingly minor technical adjustment, driven directly by the feedback in the first U.S. Army combat reports, had a major tactical impact. It reduced the dust cloud and flash, allowing gunners to use the tracer in the M62 round more effectively for spotting, thus increasing the chance of a successful second shot. This was a direct example of technical data improving the combat efficiency of the war machine. However, the most lasting tactical audit concerned the M93 HVAP round. The sheer power of the tungsten core round meant that U.S. tank commanders had to fundamentally change their ammunition allocation procedures. The HVAP could not be wasted. Official memoranda from the Ordnance Chief emphasized a doctrine of targeting by round type. A crew was essentially running two different guns, a powerful anti-tank weapon when the HVAP was loaded, and a highly mobile but ultimately insufficient medium tank when the standard M62 was loaded. The logistical audit revealed a critical weakness in the U.S. industrial base, the inability to scale up tungsten production to meet battlefield demand. This forced an alternative path, the development of new, more powerful guns, starting with the 90mm series. The 76mm, therefore, became an essential stepping stone, a necessary learning experience that paved the way for the heavier armament needed to defeat the growing fleet of German heavy tanks. In the end, the 76mm gun's story is the story of American technological pragmatism. The technical manuals provided the baseline data, the after-action reports exposed the flaws, and the industrial base responded with the best solution it could manufacture under wartime constraints. The Achilles heel was never fully healed by the M93 HVAP round, but the wound was sufficiently bandaged to allow the American war machine to keep moving toward victory. The final assessment of the 76mm M1 gun is a complex one, deeply rooted in the public domain records we have examined. It was a weapon that was simultaneously a success in terms of production, reliability, and mobility, and a failure in terms of delivering consistent, guaranteed penetration against its primary target. It forced innovation in the face of adversity, and its legacy is one of technical resilience. The American Army's audit of the 76mm gun extended far beyond the battlefield reports of late 1944. It became a long-term strategic assessment that directly influenced the future design of U.S. armor. This final analysis of the war machine was deeply rooted in the continuous synthesis of raw technical data and tactical feedback. The clearest indicator of the 76mm's status as a transitional weapon was the immediate and urgent acceleration of the program to field the 90mm M3 gun. The data gathered from the M62's failure and the M93's technical success proved one thing definitively: a larger, higher-velocity kinetic energy weapon was required. The records of the Office of the Chief of Ordnance show a frantic reprioritization of resources to equip the M26 Pershing with the 90mm gun, essentially confirming the 76mm was insufficient for the long-term fight against German heavy armor. The 76mm Shermans were not immediately retired. Instead, their role was redefined. In the final phases of the European campaign, U.S. armored doctrine shifted to what could be called force packaging. The 76mm Shermans became the rapid reaction force, exploiting breakthroughs and engaging lighter targets, while the scarce M26 Pershings, equipped with the far superior 90mm, were reserved as the designated hitters against the heaviest German opposition. The technical data determined the tactical role. This redeployment highlighted the 76mm's only unqualified technical success: the reliability of the Sherman platform. Its excellent cross-country mobility and superior mechanical reliability, which were not compromised by the 76mm gun system, allowed U.S. forces to execute the deep, fast penetrations that ultimately broke the German defense. The Sherman may have been technically outmatched in armor and main gun caliber, but its operational tempo, its ability to move and fight non-stop, was unmatched. The U.S. Army Center of Military History Analysis confirms this dual legacy. The 76mm gun ensured the Sherman could remain relevant on the battlefield long enough for the logistical and industrial might of the U.S. to produce the true heavy gun solution. It was the technical stopgap that bought the time necessary to win the war machine arms race. Furthermore, the experience of the 76mm provided a definitive answer on ammunition design. The success of the M93 HVAP round, despite its logistical flaws, proved the absolute necessity of using high-density materials like tungsten for anti-armor projectiles. This technical lesson was immediately applied to the design of all subsequent U.S. anti-tank ammunition, laying the groundwork for post-war concepts like the Armor-Piercing Discarding Sabot, APDS. The technical data from the Aberdeen Proving Ground reports on the M93 became foundational to modern kinetic energy weapon design. The final audit of the 76mm M1 gun, drawn from these public domain records, is a nuanced portrait of a weapon system caught in a technological whirlwind. It was a victim of Germany's unexpected leap in armor protection and a testament to the speed and efficacy of American industrial and scientific response. The Achilles heel of the 76mm, its insufficient standard AP penetration and weak HE round, forced U.S. armored warfare to grow and adapt faster than any German countermeasure could keep up with. Ultimately, the 76mm Sherman fulfilled its strategic mission, not by dominating its opposition on a technical level, but by compelling the entire U.S. system, from the Office of the Chief of Ordnance to the crews of the 4th Armored Division, to innovate, adapt tactics, and rapidly develop superior technology. It proved that in the realm of war machines, data, logistics, and doctrine are as critical as caliber and armor plate. The technical narrative of the 76mm M1 gun is a case study in wartime necessity. It is a story not of myth, but of data that was meticulously recorded, often tragically verified, and ultimately acted upon. Our journey through the public domain records has laid bare the complexity of this critical war machine. We began with the promises of the U.S. War Department Technical Manual TM-1904 and the 76mm gun ammunition performance data, which showed a technically capable weapon system. But this baseline data also exposed the 76mm's primary vulnerability, the sacrifice of general-purpose effectiveness for higher velocity, leading to the tactically deficient M42 high-explosive round. This technical compromise was brutally exposed in Part 2, Field Reality. The 4th Armored Division after-action reports and 1st U.S. Army combat reports confirmed the existence of the 76mm's Achilles heel, the inability of the standard M62 AP round to consistently defeat the frontal armor of the German Panther. The combat record forced a strategic retreat from frontal engagements and necessitated a reliance on flanking maneuvers and superior communication. The response, detailed in Part 3, was the technical brilliance of the M93 HVAP round. The Aberdeen Proving Ground ballistics research delivered the silver bullet, but the records of the Office of the Chief of Ordnance confirmed the logistical failure. The M93 was too scarce to solve the problem systemically. The success of the 76mm became contingent on a few precious, high-density rounds. In Part 4, the final audit revealed the 76mm's ultimate destiny as a transitional weapon. It was the necessary stopgap that provided sufficient firepower to hold the line while the U.S. industrial and scientific complex focused on the long-term solution, the 90mm gun. The final chapter of the 76mm is one of rapid technical obsolescence countered by massive production and high operational reliability. The 76mm gun was therefore a necessary pivotal success. It allowed the M4 Sherman to remain viable in the armored arms race of 1944. Without the 76mm, the U.S. Army would have been fighting with a gun designed for 1942 against tanks built for 1944. The upgrade, despite its flaws, was vital for battlefield survival and for maintaining the pace of the advance. The legacy we take away from these public domain documents is a clear illustration of how the machine of war operates in reality. It shows that no single piece of equipment, no matter how meticulously documented in a technical manual, is perfect. Success comes not from initial design, but from the continuous, agonizing feedback loop between the battlefield and the laboratory. The story of the 76mm's Achilles heel is a testament to the resilience of the American tanker, who was forced to overcome a fundamental technical disparity with superior training, tactics, and tenacity. It is a story that proves the most valuable data is always written in the pages of the after-action reports, and the true strength of a war machine lies not just in its power, but in its crew's ability to adapt.